Now we are finally ready to design abstract semantics. So here the goal is to formalize abstract program executions that soundly subsume concrete semantics. Okay. There are also multiple possible strategies about how to design abstract semantics. So some are more expressive than others. Here is an example. So how to abstract this set of numbers 1, 3, 5, 7. A very coarse abstraction is to approximate them as their type, so integer. Okay. A more precise abstraction will be based on their sign, so the abstraction will be positive. Or other possibilities like odd numbers or sometimes interval like this, okay, whose minimum is 1, maximum is 7. Okay, it describes the range of the integers. Okay, these are determined by the choice of abstract domain. So this figure shows an example abstract transition using the interval abstract domain. So that abstract a set of integers as an interval, which means that it forget about all the elements and only keeps their minimum and maximum values. Okay. So let's define abstract semantics. So first we define an abstract domain. Here we use this notation, D#, which should be a CPO. And then we define an abstract semantic function, F#. Here the function should be monotone or extensive. And what does that mean? So monotone means that the function preserves the order, and extensive means that the function outcome is always larger than the function input. Then a static analysis is to compute an upper bound of this chain. Okay, that is what the abstract interpretation says. Okay, your analyzer should compute an upper bound of this chain. Okay, that's all. Then the last question is that how to ensure that these abstract semantics and the program analysis result soundly subsumes the concrete semantics. That is our question. There are two requirements to ensure the soundness of abstract semantics. Okay, so the first requirement is called Galois connection, so denoted by this notation. Okay, this Galois connection describes the relationship between the concrete domain and the abstract domain. Okay, it is characterized by two functions. One is alpha, which is the abstraction function, and the other one is gamma, which is the concretization function. Okay. And the definition of Galois connection is as follows. Okay. For all elements in the concrete and abstract domain, if this condition holds, then the two domains are Galois connected. Okay. The intuition of Galois connection is that if two domains are Galois connected, then it means that the order between two elements are preserved across the domains. Okay, let's take a look at this figure. Suppose we have two domains, concrete domain and abstract domain here. And suppose there is an element in D called X. Okay, you can assume that this X is an initial set of states in concrete execution. If we abstract the element using the abstraction function alpha, we will have the image of alpha, okay, which is the abstraction of X. Okay, you can think this is the abstraction of the set of initial states. of concrete execution. Okay. Then if we do some computation, presumably static analysis, okay, we will have some result which is denoted by x sharp here. Okay, that is larger than the original one. Okay, original one alpha x. Then we will concretize this x sharp, okay, using the concretization function, so that we get the image gamma of x sharp. Okay. Then finally, what does that mean? Then finally, the Galois connection ensures that this concretization of x sharp, okay, is always larger than or equals to the original x. Okay. That is what the definition of Galois connection actually describe. Okay. Intuitively, what does that mean? It roughly say that this abstract domain is safe enough to compute approximation of concrete executions. Okay, that is the first requirement called Galois connection. Here is an example of a Galois connection. The concrete domain is the power set of integers, and the bottom is the empty set, and the largest element, so-called top, is the whole set of integers. Okay, and the abstract domain here is so-called sign domain that has only 5 elements: the bottom and the top, and the others represent the signs of integers. Okay, so for example, suppose we pick an element in the concrete domain here. Okay, the set 1, 10, 100. Intuitively, what is the abstraction of this set in the sign abstract domain? Okay, that will be the plus element. Okay, and then what is the concretization of this plus? Okay, that will be the whole set of positive integers, which is larger than the set before abstraction. Okay, here notice that once you abstract some information, okay, then some of them will be missed. As you can see, even though we did not do anything in the abstract world, okay, the concretization does not remember the original element. Okay, it only contains the sign information. So after coming back from the abstract domain, it will have very imprecise result. Okay, but notice that it is sound, which means that it is larger than the original input. Here is the formal definition of the Galois connection between two domains. The definition of Galois connection consists of the definitions of alpha and gamma. The abstraction of the empty set is the bottom in the abstract domain. And as you can see, any set of integers, if the elements, all of the elements are all positives, then the abstract counterpart is the abstract plus. Okay. If the set only contains 0, then the abstraction is the abstract 0. Okay. The negative case is also defined in the same way. And for all the other cases, like the set only contains -1 and 1, then the abstraction will be the top. Okay. The concretization is also intuitively defined. Here, the concretization of bottom will be the empty set, and the concretization of the abstract plus is the set of all positive integers, and the others are defined in similar ways. Here is another example of Galois connection. The concrete domain is the same, the power set of integers. Okay. But the abstract domain here is so-called the interval abstract domain. Each element is a pair of integers or infinity symbols. Okay, the minimum and maximum elements of a range of integers. The infinity symbols are used to represent something which is larger than all integers and smaller than all integers, respectively. Okay. Notice that the abstract domain itself is an infinite set, infinitely many elements and infinitely long height. Again, suppose we pick the same element in the concrete domain, the set of 1, 10, 100. Intuitively, what is the abstraction of this set in the abstract domain, in the interval domain? That will be this interval. Okay, the minimum is 1 and the maximum is 100. Then what is the concretization of this interval? That will be the set of integers between 1 and 10, okay, which is much smaller than the case using the sign domain, okay, but still it is sound. So here is the formal definition of the Galois connection. Okay, the abstraction of the empty set is the bottom in the interval domain, and the abstraction of any set of integers is described using the minimum and the maximum. Okay, the concretization can be also simply defined as follows.